Welcome to wecenter. For this video, we're trying to make our control for DOL starter for a particular three-phase motor. But most times in the market or our production, we get to see that our ACs sometimes don't actually perform the job of our control. Is usually done by the DC circuit of our production settings. That's practically, it's not always a 220 or 120 contactor coils that we get to see in our circuits while troubleshooting. So basically, we're here trying to introduce the power circuit that is still the 440, can also be the 220 volts power supply for it, and still yet independent of the control circuit. How it can be independent because all that the contactor uses for the motor, supplies to the motor, is just the contacts, making the contact go through. So the motor circuit can actually be quite different from the power circuit. So we can see that our line, we're trying to complete the power circuit supply line before we head on to introducing our control circuit with our power pack. It can actually be it's a power source for control, but it's quite different. Let's try and complete this DC, this AC high voltage power supply circuit first before we move over to the control aspect of this circuit. Here is a contactor and this our line voltage, line supply, probably an high voltage. So we're trying to make it organized. Let's make it organized, and the idea is to be neat. So we imported a miniature circuit breaker, trying to do the wiring now. For the power circuit will soon be done, complete. Yeah, in this case, there is a head. Of course, it's always on point. So power circuit is completed. We move to the control circuits that we are talking about. Control can actually, we're trying to prove to you that control can actually be totally independent. So from the power voltage, depending on the coil of the contactor, it all depends on the coil of the contactor. If the coil of the control needs 24 volt DC, then we get a power source and convert the high voltage to a low voltage, and probably AC to DC with the help of the power packs. There are a lot of power packs in the market, and we can achieve this practically and in simulations. Yeah, we introduce this fuse switch for our control circuit. Everyone knows a fuse switch and how important it is and how durable it is in electrical machines and power control. Let's introduce our normally stop, normally close, and normally open switches for our start and stop for the control here for our motor. Yeah, this is our stop push button. This is our start push button, and this is our contactor coil and our lamp. Let's take the power supply immediately and connect it to the high voltage side, of which is the AC side of the power supply. Trying to make this place organized, at least to be neat. Our circuit design has to be direct, concise, and neat. This is usually what we see in practical instances in electrical circuit designs. Firstly, it's the stop button. So let's shift this a little bit to make it at least space. You know why? I bet you know you do. Our call comes after our start, right? So our start goes, you can actually make this like the Norwegian diagram. Okay? We need our A1 done to energize the coil, and also we're going to introduce our normally open contact. Let's link our indicator lamp first before we head on to bring that down. Yeah, neat. Our normally open contact, same contactor, and actually we use this for lashing our circuit. Push button usually pull back when it's on. So with the help of this lashing of the contactor contact, normally open that goes to normally close, our problem is solved. So let's connect our negative terminal to supply our coil and complete the circuit. Also for our indicator lamp, so this coil here is energized when this coil goes down. So when it's energized, the transverse power goes to the motor as with the help of the control circuit. Don't forget, our power supply can be, or for the control, can be a DC or an AC. So by simulation, we on the power circuit and it's waiting for the contactor to be energized. So we'll go to the control, put it on the contactor. You see the DC pass through, but the coil is not yet energized until we have to press our start button for the motor to start running. So when we're on the power supply alongside with the circuit supply, you see on, and our motor is actually running. So you can see we can achieve this when we don't have a 220 or a 440 volts coil, depending on our configuration. So stop, start, stop, start. It's the idea of controlling the motor. Stop and start. So the motor runs because the coil is energized. So the contactor is closed. The motor starts running. That's it. Thanks for watching. Hope to see you next.